let's review a little bit. In this problem, let me turn on my marker here. If I wanted to rewrite the logarithm as an exponent, this would be 4 to the second power is equal to 16. Here, this would be 9 to the negative second power is equal to 1 over 81. Here, this would be 32 raised to the 2/5 power is equal to 4. And here I'd have 64 to the 1/2 power is equal to 8. And that would be rewriting a logarithm as an exponent. Now, in order to write an exponent as a logarithm, remember, this is our base here. So this would be 5 to the 125. This one does not make sense. Is equal to 3. That does not make sense. Oh, I got to put a log in there. All right, so log base 5 of 125 is equal to 3. That makes more sense. Log base 9 of 27 is equal to 3/2. Log base 4 of 1 over 64 is equal to -3. And log base 24 of 1 is equal to 0. So you should be able to rewrite logarithms as exponents and exponents as logarithms. Now, we also talked about solving as long as the log, if we have one log on both sides, we could just cross them off. Oops, I'm going to turn on my marker here. So this would just be x plus 1 is equal to 6, so x equals 5. Here I have log base 2 on both sides, so I could rewrite this as x minus 3 is equal to 9, so x equals 12. And here I could cross off each log, so this would be 2x plus 1 is equal to 15. So 2x equals 14, x equals 7. Okay, so being able to solve using the one-to-one property is a good skill to have. Now we're going to be talking about properties of logarithms today, and we're going to be talking about condensing logarithms, rewriting logarithms as a single logarithm, or expanding them. But most of the times when we use the properties of logarithms, we're really trying to write as a single logarithm, because that's going to help us when we start solving equations. But not all the time. Sometimes they will ask you to expand it out. So here, this is called the product property. If you have the log base a of u times v, that equals the log of a u plus log a v. Now, and it also works for natural logs too, usually you'll be given something like this: the log base 2 of x plus the log base 2 of, let's say, x plus 5. We can rewrite this as a single logarithm, and that's what they mean by rewriting as a single logarithm. There's a plus sign here, so I know I can multiply these since the logs are the same. So I could rewrite this as the log base 2 of x times x plus 5. That's what this product property says that we can do. Now, the quotient property, if there's a minus sign here, then we would subtract. So if this was the log base 2 of x minus the log base 2 of x plus 5, now there's a minus sign here, so we would rewrite it as a single log, but this would be the log base 2 of x over x plus 5. Okay, and then we also have a power property that says the log a u to the n. We can, anytime you have an exponent here, we can bring that n to the front of the logarithm. Okay, so I could, if I had something like the log 5 of x plus 2 all raised to the third power, I could rewrite this as a 3 log base 5 of x plus 2. Okay, that exponent can be moved to the front. So those are the things that we're going to be using today to simplify logarithms down. And then that leads us to next week when we start solving. We're going to be using these properties. So for example, if they gave me something like this, express log base 6 of 4 plus log base 6 of 9 as a single logarithm, then simplify. Well, since it's a plus sign, I am going to multiply. So this is going to be log base 6, 4 times 9 is 36. And then it says simplify. Now most kids, they're like, oh, okay, so this is written as a single logarithm. But if I simplify it, my answer is 2, isn't it? Because log base 6 of 36 is just plain old 2. That is simplified. If I did this problem here, I'd have log base 5 and log base 5. Now, I think I might simplify it first because this is going to be a pretty large number. So log base 5 of 25, isn't that just 2? And isn't log base 5 of 625, is that 4? 5 to the 4th power, I'll get my trusty calculator here. 5 raised to the 4th power is 625. So that would just reduce it 4. So this would be 6. Now I could rewrite this as a single log. Log base 5 of, okay, I don't know what 625 times 25 is. 625 times 25 is equal to 15,600. But I'll bet you that 5 to the 6th power is 15,625, so this does reduce to 6. Okay, so part of your assignment this week will be rewriting logarithms as single logarithms. You're going to condense them down. So in this problem, it says simplify log base 2 plus log base 3. Well, isn't that just, so it's a plus sign in there? So I'm just going to go log base 10, because it's not written, but I'm not going to write it in there. So that's going to be 6. Which logarithm is equal to this? Well, there's a plus sign, so I'm just going to rewrite it as a single logarithm. So that's going to be log base 6 of x minus 3 times x. Now I could put the x out in front if I wanted to, or I could multiply it through. So I could rewrite this as log base 6 of x squared minus 3x. That would also be fine. So I'm just simplifying that logarithm down. Now, and we already had this, I'm not sure why I split this up, but if there's a minus sign, we just rewrite it as instead of multiplying these two terms together, we divide it. So that would be 16 divided by 2, or just 8. So if I have something like this, it says express log base 5 of 100 minus log base, I think this is opposed. I think that 5 kind of got mixed up. All right, so let's rewrite this. I think it was supposed to be this. I think it was supposed to be log base 5 of 100 minus log base 5 of 4. I just think that when I brought the problem over, it kind of got mixed up. Same thing with this one. I have a feeling it's supposed to be log base 5 of 100 minus log base 5 of 4. So if I rewrite this, exactly the same problem. Guess I only have to do it one time. All right. So if I was going to rewrite this, I'm going to rewrite it as a single log. So this would be log base 5 of 100 divided by 4. So this is going to end up being log base 5 of 25, which really simplifies down to just 2. So all of this just becomes 2 for my answer. So if I give you a problem like this, log base 8 of 3x minus 1 minus 5 times, oh, this one's a little tricky. That 5 in front, we have to get rid of that. We can't just leave that there. How do we get rid of it? Well, remember that rule that said we could bring an exponent down? Well, that means we can take it back also. So I'm going to put that 5 here. So my problem is log base 8 of 3x minus 1 minus log base 8 of x to the 5th. Well, it's a minus sign here, so I'm going to just rewrite it as a single log. So that gives me log base 8 of 3x minus 1 over x to the 5th. And that would be my answer. So anytime you have a number out in front, make sure you put it behind there, because it will really mess the problem up if you do not. All right. In this problem, it says to solve. Okay, so let's condense this. Okay, so if I want to rewrite that, it's going to be log of 30 over 5 is equal to log of x. Well, 30 over 5, so that's going to be log of 6 equals log of x. Now remember, we had that rule that if there's one log on one side, one log on the other side, we can just cross them off. So x equals 6. Awesome. So the power property, and we already talked about that. If you have a power, you can bring it out to the front. And it really helps out a lot when you have problems. You want to bring that exponent out in front. But if you're condensing, you have to take the number out in front and take it away. Okay, we already talked about these properties here. So in this problem here, it says express 2 times log base 4. I'm sorry, there's no base, it's really base 10. So 2 log base 10 of 4 plus 3 log base 10 of 2 as a single logarithm. Well, I can't rewrite them as single logarithms if there's numbers on front. So I'm just going to rewrite this as the log base 10 of 4 to the second plus, and then I'm going to bring the 3 up, so that's going to be log base 10 of 2 to the third. Well, 4 to the second is 16, so this just gives me log of 16 plus log of 2 to the third is 8. So now I have to multiply that together, so that's going to give me log of 16 times 8, which is 128, and I'm done. And that is it. Now, let's say I gave you a problem like this. Here, write as a single logarithm. Well, first thing I'm going to do is I'm going to bring the 1/2 up. So this is, I'm going to rewrite it as log 16 of 1/2. Well, what is that? 16 to the 1/2 is really the square root of 16, which is log of 4. Plus, well, I'm going to bring the 3 up. Well, 1 to the third is just 1, so that's just going to end up being log of 1. And now I can rewrite this problem as log of 4. Because multiply it, because there's an addition sign there. All right. I hope to see all of you at the main lesson on Monday. Kind of cool stuff. Have a great week. Bye.